Hello, I'm Roman, and welcome back to the series of videos Neural Networks from Scratch in Golang, where we're using this book called Neural Networks from Scratch in Python, but we writing everything with the Golang. And at one of the previous videos, somebody commented that the font size was not big enough, so it was hard to read the code. I usually decreased it right before recording these videos, but probably it wasn't enough for you to see. Please let me know if this font size is okay or I need to make it even bigger, because there is always a trade-off between reading it on the video and actually recording this video. So even this one is a little bit big for me, but please let me know if I need to make it, I don't know, like this. Yeah, maybe I need to do it just like this. And probably, yeah, that should work. Okay, in the previous video, I finished with, I'm still on the chapter 18 model object, where I'm writing the model struct that encapsulates all of the logic behind training. And currently I have two models kind of working. So I have the binary and I have the categorial. Well, not. I have the binary and I have the regression. And the last thing from this book that we had the first model, which tried to predict several output classes. And in order to do this, I need to finish a couple of things. And there is one thing, like if you remember previously, we had this, what's called this object activation softmax logs categorial cross entropy, and that was combined version of softmax activation. So we had, for example, softmax activation, we had categorial cross entropy loss, and it was like calculation of the activation first and then the categorial cross entropy loss, like forward, well, actually backward method was too long, because you can see if you take a look here, right? This is pretty small implementation and it encapsulates backward both for the loss and activation. But if we take a look, for example, at categorial cross entropy loss, this one, just the backward method is kind of big. Yeah, you can see, and that's only one. By the way, do I need? No, no reference. Yeah, actually, I can, I think, remove it, right? And it should work. Still, let me try. Okay, so what I'm going to do? Well, there are two options what I can do here. The first one is I can, for the categorial, I can just use the softmax activation function and the categorial cross entropy loss, and that's it. The only downside that it will, it will work much slower than this combined thing, or I can think of the way how I can use this optimized version and integrate it into the model. The problem that I have with the suggestion of the book is inject this check into the training method. And why I don't like it, because it goes in a way that the model should know about two concrete classes. So the one that we have the activation softmax and that we have the loss categorical cross entropy loss, which makes the model depends on these classes, and in my case on these modules. And it kind of kills the whole idea of hiding everything behind the interface, etc. I mean, even now I have this in the train model, I have this downcast, this one, right? And I need this to pass into the optimizer only actual layers. Because if we take a look at the layers interface, it has much smaller things, but if we take a look at the layer, we have tons of the things dedicated to different optimizers. For example, this is used by the stochastic gradient descent optimizer, this by, I think, others, and we have the regularization thing. So I don't want to expose it into the interface because it makes no sense, and the interface is shared between the activations layer and the dense layer. So right now I need to come up with a solution how I can do this. And I mean, what is it? The last step is during the backward pass to check if the object is set to use it. So the idea is, where is it? So it checks on the finalize method if we have the activation softmax and we have the, so if we passed the activation softmax and as the last layer and the categorial cross entropy loss as the loss function, then we create this object just to use the backward method, because the backward method is what we're trying to optimize here. And you can see that, where is it? In the backward method, there is a special case for this. So if we have this softmax classifier output, then we do, then we call the backward methods this optimized one. Then we take the D inputs and assign it to the last activation, because we're not calling the backward on the activation function. And then we do the actual backward path, because this is the normal version. I really don't like this. And yeah, they even suggest that we just leave the backward path and that's it. And I don't know how to make it better, because currently what it does, it uses the for method from, from the normal implementation, like from the activation softmax and the categorial cross entropy loss. But then it has this combined version. Okay, so the first thing, actually, I need to, I'm going to move this file into, nope, move, no, wait, move, loss, yeah, okay, this one, yes, I need to change the classifier. And to change the package, yes, I don't need this anymore. Undefined loss, I don't need it because I'm already in the loss. And yeah, this is the tricky part. Because if I take a look at the train methods and for the backward, no, actually for the train, We call the backward on the model, which will call backward for the loss function and then for all of the dense layers. Wait. Okay, so first it call. Oh, right. So first it calls the backward method on the loss function, then it calls the backward methods on the activation layer. And how I can inject things here? I mean, what I can do to have this weird implementation, I can. What I've been thinking, because for the backward path, I mean, it calls the forward for the activation, and then wait, we have the forward. Where the forward is used? Train, not train. So we call the forward, that will be the result of the activation layer. Then we call calculate loss, that will calculate the results. Wait. It will call loss for the interface. So in this case, it will call this one. What I'm trying to think, if I can, write it in a way that, for example, forward. Okay, so it calls an activation and the loss. The problem is that we need to get these results from. Okay, so let me go back to the train. So what it does, so we have the output that is called, the output returns from the activation. Then we take the output from the activation and we go into the loss. And then we call forward. So in this case, for example, if I'll pass the softmax, it will call this one and it will create the output, right? But then we going to calculate loss, and calculate loss in normal case will do this. It will take the predictions, which is the result of the activation layer, and then it will calculate negative log likelihoods and return it, but it will return it. Yes, and then it will return. Then it will return it here, so we can calculate the loss. Then we can do the same. Okay, so if we take the model on the train, for example, imagining that I have the loss. I have the loss function and I have the activation pointing to the same function, well, to the same object. But I think the next problem is not in the interface. So the layer interface have forward with inputs and is training, but if we take a look at the loss, we have the forward with different. So my idea was that I will cover it with generic. I mean, I will do it in a way that this object will implement both interfaces. But the problem that the loss interface, well, at least currently the loss interface and the layers interface have the forward methods, but they are different. And Go doesn't have the function overloading, which actually, if it will have, for example, in case the code has the function overloading, it will make my life easier here, but currently I cannot see how I can implement this unless I will rename forward and backward methods in one of the interfaces, and I will have two functions, and then, for example, inside this object no, this one. Inside this object, I can determine from which interface it's called and do some stuff. For example, if the forward method was called as the layer interface, I will call the activation forward. If it's called forward as loss interface, then I will do calculate. But then, for example, if there is backward methods, if it's called as what's called as the layers interface, I can ignore it, and when it's called as the loss interface, I can do the calculations, and that's it. But it's not available for me. So what I can do? Well, first I can, not enough. What is 3? I think that should be false. Yeah, but so what are my options? The first option that I have is just do not use it and go forward. Just make sure that those things are correct. Yeah. But maybe, I mean, okay, so I will think about this. Find files to do. Okay, so maybe what I actually need to do. Okay, I've done this, checked how the model, yes, and refactor loss functions to take dense instead of, yes. So maybe actually what I can do today is, first what I've been done so far. It was moved. Okay. It's not training. Okay, for the loss that I don't need it, it's kind of, well, it's actually moved. Unfortunately, well, it's bad that it wasn't able to track it as moved. Okay. Model. Okay, so what I did. Transform binary wire. Okay, I pushed the last changes. What I actually can do, because I need to think about this optimization, but I still have some stuff that I need to check. And what is happening? Okay, seems that was the problem, right? To do. Okay, so looks like there is a trick how to make the line be always on the center of the screen, and that's setting the scroll off on a very big number. But the problem is it started to mess with with the rendering for somehow. Okay. Okay, so trying to fix the forward this. So that should take reference to the dance, and same should be here. Right? So what it will make for me? Well, first I should have the building errors. Yes, can use target. That's true. So let's do this. Well, first, calculate loss should take the dance as well. And that's it, right? What it formatted fails. Dance. Right. Okay, then we do. By the way, do I need? I'm not using it, right? No reference found. No reference found. And no reference found. So I don't need this file anymore because I have the accuracy object right now. So okay, we have the base loss. Okay, then this one. No. By the way, I think I can, grab all of this. Really? Target. But I do have. Maybe I have to incarnate it like this and plot 64. So I have forwards, backwards, forwards, backwards, forwards, and backwards. Okay, so how can I go and add to the like now vim add telescope add to quick fix list. Quick fix only in telescope. Telescope has a picker. I used to ditch the. How I can do Control F. No. Location quick fix. Yeah, probably I need. When I use only terms such as find Control Q to go. Control Q. Oh, okay. And then I can do this, right? Can have target. Load 64. Load 64, and I can replace it with target math dance G. Cannot make changes, modifiable is off. How I can make it modifiable? Okay, so I spent already 30 minutes on this episode and all I did was nothing, basically. So let's aim for one target and I will do it. Well, first, let me finally fix, continue with changes for this one. Okay, I will just make it compile, right? And in order to do this, I will introduce a new target. Where is its data, right? And to fix it, no, and to do fix it. What happened with my plugin to highlight to-dos? Okay, and so that should be this, right? And this and this. Okay. Then there is a backwards method. So right now I'll focus only changing the API. Okay, I will do the same here. I will need to fix it and how many times? I think 5, right? Okay, so this one is fixed. Going to the next one. Oh, that will be an interesting. So because it works with the unsigned integer and I'm changing it to the tens, which will make the situation much more interesting. Okay. What I'm going to do, I'm going to, oh, no. Again, to do fix it, I will create a new, and I will just take the data, 5x, 5x, and 5x. I mean, that should work the same. Actually, I have the conversion here already, but when we have, oh, okay. What do you mean? 1, 2, this one, okay. Then I think we will have same here, and will be math again. Then why I always hit the wrong button? Math and T, right? And then we have this. We should have same T. Yeah. As I said, right now I will try to please the compiler. And we'll continue in the next video with the rest. Is not declared. No. And the rest is softmax loss, right? Right, this one is okay. What it means? It means that finally I can do this, right? I can pass the reference to the target. I can do the same here. And oops, no, this one. And once again, do I have errors anywhere? Yes. And okay, so that should be buildable and it should be runnable. Yes. Okay. So it works. So what I did, at least, I did this. Already some fixed models. Okay, I will leave it for now. Check how the data is passed without pointer receiver. So another thing that I have, not this one, grep. I have the to-do list. And yeah, it's a good question. Fix target pass, that's fixed. Define dimension for y. Yes, then I need to, that will be my next thing. Mean if vertical, should I change it? How I'm going to change it? That will return again math dense, right? Then what it will do, we will have the y, one column, same number of the rows. And what should we do? We should treat sets at ix 0, and that will be unsigned int, but maybe I don't need to actually do this class number. I think I can just pass the class number and that's it, because we will need to convert that back anyway. Oh. Any else to do's? The one that I can fix easily today. And regarding this one, I've been thinking that I can do it in a very different way. Let me show it to you. So for example, I have two. The one is softmax activation. Can I make it bigger? No. Can I make the font size bigger? Wait, where is it? Text. I know. 50. Okay. Okay. I have the softmax activation, right? Implemented. I have the, what's called? This one, categorial cross entropy loss, implemented too. Okay. I have them implemented too. And then I have this optimized version, right? Okay, I have the softmax, right? I have the categorial cross entropy loss, they all implemented. And I have this, okay, and I have this optimized version, right? And this too has its own interface, and this is kind of the optimized version. What I can do, I can create this node second implementations. They will follow the interfaces, so that will, now this one will have the layer interface, it will be the layer interface, and it will be loss interface. What? And they both will use this one under the hood. Maybe that could be actually a fix. No? So what I'm thinking right now, maybe I'll explore this idea in the next one. So I'm creating another version of softmax activation and the categorial cross entropy loss with its own interfaces, but into the both I will pass this activation softmax loss categorical cross entropy loss implementation, and the model will work with these classes as usual, but inside I will implement it in a way that it will work with these ones. For example, when I need to call the backward method, I will call it kind of 2 times through the interface. And actually, yeah, this softmax activation will use, I think, like this. Well, they will do it through this one, but for example, for the forward, we will call the forward of the softmax, then I will call the... So they will be kind of like a proxy, working only together, so you cannot use it separately because it makes no sense. But once you will need to use backward method, I will kind of proxy it into this one in one case, and in another case I will just ignore the call. Maybe that's actually a solution for my problem. Yeah, I've been just thinking about this. Well, let's see on this. Well, I mean, I started this refactoring, so I kind of need to finish with this to-do list. Well, basically this one. And then I can get back to this optimized version. Hopefully I will do this in the next video. I mean, both things, so we will see. I will stop for today. It's clearly not the best day for me to do something with the coding. I have this idea that just came here to me, this one. So maybe it's actually what I had to have as the result today. Thank you for watching, and I see you tomorrow. Bye-bye.